Hello everyone, welcome back to our Rhino and Grasshopper tutorial. Today we can talk about how to build this unzipped wall inside of Grasshopper. So first we're going to pull up Grasshopper and then we're going to introduce a new component called range. So what range will do, this side is its domain, it's 0 to 1, and this side is steps. So if I put 22 here, they will evenly divide this domain 0 to 1 into 22 different segments. And of course, they will have 23 data points, right? If you divide it into 2 segments, you have 3 data, 0 to 1, and you will get 2 segments with 3 data points, right? So let's do 22, and we have 23 data points. And also our old friend, series, what's the difference? And when we have series, it's 0 to 21, and with 22 data points. And here there are 23. So in order to make them even, I'll come over here to expression x minus 1. Okay, that's the first thing we will do. Now we have 22 data points on the left and 22 data points on the right. Then we will use those 22 data points to generate a bunch of points. Okay, so I will go to vector and I will use this construct points. I'll use this as a y value, bring it here. So I'll get a bunch of data points. And then I will use this as the x value. So we will see something like this. Okay, but that's not what we want. We want something in this manner. Okay, and how are we going to do that? Well, we're going to introduce a new tool called Graph Mapper. So it's right here. And I will come over here, choose this thing, Gaussian, and I will explain to you what it's doing in a second. I'm bringing it here and bring it in. You will see this kind of flow. In order to make it more clear, I will multiply it a little bit by using this tool multiplication. I'll type in 22.22, bring it in here, and bring it into X. And let's take a look of what this graph mapper is doing. So we're going to change to a easier version, which is this Bezier. Imagine this is a XY coordinates. This is X and this is Y. Okay, and the original data is 0 to 1. Here also 0 to 1. It says here 0 to 1, 0 to 1. And there is a mapping rule in between. This is the input value here. Right here is input value, and right here is output value, which is our target. Okay, and then let's take a look what it's doing. So originally it's 0 here and 1 here. So right now it's a straight line. It says 0. Okay, input is 0 and output is going to be 0. And also here 0.5, the input is 0, the output is on the y-axis 0.5. Okay, but I'm going to say that wait a second, if I drag this around a little bit, if I move this curve in this manner, okay, and then in the new result it'll be something like this. Let's change the color to purple. It's saying that wait a second, it's no longer 0.5. This is a new value. Okay, it's right here, and we're going to project it to the y-axis. It's going to be, let's say, 0.8 instead of 0.5. So that is what this path mapper is doing. It will take this input value into the map on the x-axis and then find this specific value. Okay, let's say 0.6, and project it to this curve and then reverse it to the y-axis and find the value 0.9. Okay, so what this is going to give you is if the original input is 0 to 1, the result will still be 0.1 by default, but then the data in between will be changed dramatically based on its position to this graph. So if we're going to use this kind of graph or this kind of remapped position into our 2D environment, we're going to see something like this. So this is a complicated concept, but all you have to remember is this graph will be projected to the 2D environment if you are using it in the right way. So let's take a look of what this have done in the 2D environment. Originally, we just have a line, right? Remember, we had a line like this because we set up the data. Here's our original data. Let's make it easier to read. Let's make it 11. We minus 1 here, and then we will divide this into 10 segments. We'll get 11 data points. They are 0, 0.1, 0.2 to 1. Okay, And those red lines are exactly those data points. Here is 0.1, 0.2, 0.3, 0.4 until 1, okay? And then this is the input. And look, let's take a look of the output here. The output is exactly the same. Why? Because right now it's a straight line. But if we change it a little bit, okay, we make it flat, which means that the small number here, 0.1, will be as close as possible to 0. And let's take a look, okay? Originally, it's 0.1, but after we use this mapper, it becomes 0.002794. So it's very close to 0. But right here, if we drag this up a little bit, right here is a 0.9 position, right? Originally, it's 0.9. It becomes 0.987611, which is extremely close to the value 1. So we are using this kind of mapper to guide the distribution of those data. And then we will bring this data into the X value of those points we're generating. And that is the whole point of we are using those mapper to generate our data. Let's bring it back, our Gaussian distribution, and we got something like this. And right now, let's make it smaller, and let's play with this Gaussian distribution a little bit. We're going to make this flatter, and then we're going to drag this up a little bit. Make sure that you don't touch this left and right. We want to make it symmetrical on the left to the right. Then we can move this a little bit. And of course, we can increase our data set, increase the multiplication. We're going to set on this x-axis. Remember, the result will still be in between 0 and 1. And right here, particularly, this looks something like 0.6, and that's not what we want. That means that after this graph mapper process, so the domain from this mapper will become 0 to 0.6, and that's not what we want. We want to make it bigger. So we will keep the correlations in between, but make the overall domain bigger from 0 to 20.12 or something like that, and then project this onto the x-axis. We will get this result. And right here, I want to generate a bunch of points, right? For example, I want to generate a bunch of points like this, and you will see why I'm doing this in a second. In order to generate those points, what I will do is I will go back to range, but this time I'll give it a different number. Let's do 20. And of course, I will change to expression and type in x minus 1. And I'll take series again. I'll bring this in, and then I will get a bunch of data, right? 20 data set from 0 to 1. And then I'll multiply this data with the x values that we just generated here, okay? And then I will graph this data. So let's take a look of the final result. Once we graph this data, we will bring this into the x values, and we will get this, right? Let me just change it to 30. So make our explanation a little bit easier. And also let's make this number a little bit easier. And let's change data here to 11. Let's take a look. We got this data from range 0 to 1, right? 0.1, 0.2, so on and so forth. And right here, we got another set of data. It's the data that has been generated by the graph mapper, right? Which are those data outside, those points. And then we are saying that, okay, each of those points, like right here, will compute, will multiply each of those data points, 0, 0.1, 0.2, 0.3, all the way to 1, okay? So, for example, it's basically saying that, oh, I want to call the value at this local point, and then I will multiply this value. It's x. I'll multiply x with x 0.1, and then I'll get this data here. And then I will multiply x to 0.2, I'll get this data here. So on and so forth, this is 0.5, and this is x times 1. So I got those data by multiplying 0.1, 0.2, 0.3, all the way to 1, okay? And then I will use those generated data as an x input, right, of our coordinates for our construct points. And then I'll get this list of data, okay? And then you're going to ask me why I'm doing that. Well, here is why. Remember, I use this series right here. If I bring this into the z value, and you will see something like this. You say, this doesn't make any sense. That's because we haven't changed the graph settings here. Let's take a look of those inputs. So right here, we have 330 values, which is 11 lists, and each list has 30 data. Right here, we have one list, and this list has 30 data. And right here, we have one list, and this list has 11 data inside. And we see this kind of uneven relationship in between. And then I will graph this, and we will get something like this. So the data structure is hard to understand, but please take a look and understand why they have this kind of correlations in between. And then you will say that, oh, this is not what we want. This is exactly the opposite way we want. So what I will do is I'll come over here and type in reverse. Okay, so I reversed this kind of relationship, and then I'll get this. And now the beauty of this is you can easily change everything by yourself by dragging this graph around, right? Also, you can change this value. The next thing I'm going to do is I will take a look from the front view, and then you will see that, well, this is a straight section, and that's not what we want. Let's take a look of our reference photo. You can see that this sections in between is not straight. They have this curvature on this direction. And how are we going to do that? Well, very easy. We can do that by changing the distribution of the data points again. So remember what we did here is we multiply the x values with 0, 0.1, 0.2, all the way to 1. And we want to change this set of data by using this graph mapper again. In order to have that curvature, I will pull up this graph mapper one more time, and then I will find this type, Bezier, and then I'll bring this in. Let's take a look of the result. We talked about this before. We want to have something like this, maybe something like this, and then we will replace this data distribution with the data right here, and we will get something like this, right? And let's take a look of our reference photo. Once again, it's vertical here, flat here, and then vertical back. Okay, so let's take a look. Vertical here, and flat here, and vertical there. That's pretty good. Also, I'll change the magnitude a little bit, right? And then I'll get this data. Okay, so pretty decent, and this is exactly what we want. So the next thing I'm going to do is I will delete all those panels to make our life easier. So the next thing I'm going to do is I'm going to come over here and check this image one more time. I'll point out something to you. In each of those units here, right, there's one box here, right, and then there's nothing here. Again, there's a box here, and then nothing here. A box here, and then nothing here. So there's this kind of relationship around all those boxes. And what we want to do is we want to take some of those points out of our way. For example, if we want to keep these points here, then we want to keep this out. We want to keep this one out. We want to keep this one on. And we want to keep this one on. And we want to keep this one out. In order to do so, we have to play with some tricks over the data structure. And first, let me flatten all the data here. So ideally, this is what we want. We want to select the following data. This one, this one, this one, this one, this one, this one, and we're going to start from here, this one and this one, all the way going on, right? So in order to do so, first we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? We cannot have even number of points. Otherwise, we will select these points again. Imagine we have even amount of points. We deselect this one, and then we will have to select this one again. So we have to make sure that on this direction, there are always a odd number amount of control points. Okay, we're going to change that in our input later. And then ideally, we want to have flat data structure. This will be first point, second, so on and so forth. So we will flatten everything. In that case, we want all the data into one list, right? So instead of having one list here, one list here, one list here, one list here, we want to get rid of this data structure and put them into one list. So in that manner, we can have this kind of continuity. Here's a list from here, all the way to here, and then all the way to here, so on and so forth. In order to do so, I will select this tool, flatten the tree. right? We explained this many times before. Let's take a look. There are 330 values. There are 11 lists, and each list has 13 data. We want to get rid of that right here. And right now we have one list, and this list contains 330 locally defined values. Okay. And then we want to jump select, which means we want to select this one, this one, this one, and this one. And in order to do so, again, it's very easy. We will use this tool, list item, right? We will bring this sets of data in. This is what we want to select. And then we will come over here, use series, right? We want to see how many data are in this list by using the thing list length. And then we will bring this in. Right here, there are 330. I will come over here, choose expression, say x divided by 2, because we only want half of those points, right? And then if we select it, it will be something like this. You will only select the top half instead of the bottom half. And that's not what we want. And let's take a look of the data here. We have 0, 1, 2, 3, 4. That's not what we want. We want 0, 2, 4, 6, 8, so on and so forth. So we will change the step into 2 right here. And then let's take a look. Well, that's still not what we want. Why is that? That's because ideally what we want is we want the data in this kind of order from here to here. And then the next data in the list will be here and all the way coming down. And then the next data in the list will be here and all the way coming down. But right here, they are in this order, right? This is the first data, data 0, data 1, data 2, in this kind of order, and we want to change that order. And then we have to come over here to use this tool, flip matrix. Let's take a look what this is doing. This is the original data set, and this is data set that has been flipped matrix. And let's take a look. In the original data set, we have 11 lists, and each list has 30 data points. But after we flipped it, let's take a look. Now we have 30 lists, and each list has 11 numbers. Okay, so we kind of flipped this order. And let's take a look again. We go all the way to the bottom. In the original list, the last list is list 10. And this list 10 has 30 data points. And after we flipped it, let's take a look. Let's go to all the way to the last list. It's list 0029, which means we have 30 lists here, and each of those 30 lists has 11 data points, right? From data 0 to data 10. So we kind of changed this order, which means that the original data set is 0, 1, 2, 3. After we flip matrix, here is data 0, and here is data 1 and data 2 and data 3, so on and so forth. This is what we want. And we're going to use this to replace our original input, right? And let's select this again. Voila, we got what we want. We got this kind of selection as we expected. And then I'm going to come over here to vector and choose YZ plane. Okay, and then I'll select this, and we got those planes. Now we're going to draw a bunch of rectangles or squares on this YZ plane by coming over here, type in rectangle. I'll bring those planes as the original points. And then here are the domain. I will come over here, set domain, right? And by default is 0 to 1. I want 0.5 because again, each of those points, they are 1 unit apart. Okay, so I want the length of the side of each rectangle will be 1. So I will set the domain as minus 0.5 to 0.5. So minus x. So minus 0.5 to 0.5. And then same as on the y direction. And we will get those things. And if we go to the right view, we will see that all those projections of each of those squares aligns very well with the adjacent squares. And then I will use those to extrude those members by using the tool extrusion. And of course, this is the x-axis. So I will put x here and then squares here. And I will change the input 3.3. Let's say that's too big. Okay, we got something like this. Then I'll come over here. Right here, you can see that the length of each of those units are keep changing. And in order to take care of that kind of relationship, we have to do some tricks also. Before that, let's make this bigger. So let's make it 50. And let's make this 20. and let's see if there's something wrong. Okay, if we make it 20, you see that this kind of relationship has been gone, right? Remember we explained to you why this has to be an odd number. So let's check it to 21 and take a look. See, this kind of relationship comes back. Okay, if we do 20 again, 20, this line got completely empty. But if this is 21, okay, this relationship comes back. So I will just come over here and change it to odd number only. So no matter how I'm going to change it here, it will always be a odd number. Okay, so let me bring it back to 21 and keep it that way. And then I will come over here and change the extrusion length. How much they will be extruded will highly depend on the X values of each of those points. Let's hide those first. So again, we will make sure there's this correlation between how much those squares are going to be extruded along the x-axis and their own coordinates on the x direction. Okay, so I'm going to come over here and find each of those points. They are right here. We select all of those points. We want to extract all of their x direction value. So we have to come over here to vector. We will find this, deconstruct points. So we can find the x value of each of those points and bring this in, and let's see what's going to happen. Let's extrude it. We see that, wow, there is this kind of relationship we were expecting, but it's just too extreme. Right here, there's no thickness of those extrusion at all because those points, their x values are 0, and we don't want to do that. We want to put a floor and ceiling on those numbers, right? So we will come over here, come to remap. We explained this many times. This domain, we'll come to math, bring the bounds, and give it a domain. So let's say the smallest will be 1.00, and the biggest will be 3.33. Let's see if it's appropriate. And we will bring this value into the extrusion and we will get something like this. So this looks very decent for me. And let's see if it works or not. Let's bake it and take a look. Okay, so we have one unit here. We have nothing on this cell. We have one cell here, one cell here, one cell here, one cell here, right? This is exactly what we want. Perfect. And then let's delete all of them. Let's go back to our reference photos. We come to this one. We see that on the left, we have this kind of extrusion here. On the other side, we have a different logic, right? How are we going to do that? So next, I'm going to come over here and I will clean up all the inputs. I'll make sure that they are not going to be repeated. And then I'll select all of those components, click the left key, hold Alt, and drag them. And then I'll come over here, check the expression to -x. So I'll flip everything to the other direction, right? So I'll go to the top view. It looks something like this. But in order to make it normal, and also I have to come over here, change the expression to -x also. Let's take a look. Let's go to the top view. Still something is wrong. The reason that something is wrong is because right here, the source is -9 to 0. And then right here, because we flip this on the x direction, so all the values on this side become minus. And that caused some problems when we did the remapping here. In order to fix that, we have to come over here to the remapping and give it a absolute value. So I will come here to absolute value. I'll bring all those values right here, and then I'll also bring those absolute value to the input here. And then let's take a look. So everything has been fixed here. So again, when you're remapping the data, sometimes the negative data will cause problems and you have to keep an eye on that. So now I can change the shape by playing with this right here. But then you will be like, wait a second, this doesn't look like what we have on our example, right? We have this kind of shape here. Well, this kind of shape reminds me of another type of math, which is a sine graph, right? So I will select over here, choose sine, and then I will drag this a little bit. And then I'll bring this up a little bit. Okay, isn't that much better, right? And then I will take a look which part we still have problems. And we realize that, oh, wait a second, those points right here, these should be overlap. Well, how we can solve that problem? Easy. We know that those points are barely moved. So for those units, the extrusion value should be the same, which is the minimum value right here, which is 1, right? So those are the value for the extrusion, which is the flooring, which is 1, right? As long as we know this number, well, it's easy to fix. So we will move those to the left for 1 unit, and then we can overlap them. So I will do that. I will move them, move all those frames to X direction for 1 unit. By default, it's 1, so this is good. And then I will bring this let's take a look. This is what it looks like before. This is what we will look like after. Okay, so that's exactly what we want. So let's take a look of this image particularly and see that there are a certain number of units on this direction. We should make this like taller, right? So I will come over here, change the input 21, make it taller. And also we see that it's more vertical here and then coming down. In order to solve that, we can come over here and we can change that by changing the graph mapper here. Let's take a look of the reference again. There's too much. All right, so I will again come over here, decrease it a little bit, change the graph. And I just realized that this magnitude might should be just separated. So I'll come over here and make a copy, make a new data, and then change it. Again, we're going to take a look of this right here. Perfect. So that's the overall shape. And let's take a look of the real project here. And then we realize that, okay, this one right here, it is checked, but on this side is empty. This one is empty, this one is checked. So this kind of distribution is also a problem we have to solve. And how we can do that? Well, we're going to come over here. This series number here, this defines which points we're going to select, and we're going to extrude things from there. And if we change the input for the start point, we will put it 1 here, we will change everything. Okay, perfect. And then when we bake everything, we will not have that problem anymore for the overlapping. Let's take a look, right? We have 1 point here, 1 point here, 1 point here, 1 point here. And then they will start to separate at these points and nothing will overlap. And let's take a look of the original photo again. They have 1 here, 1 here. And then for this one, they don't have any units on the same level, but they have 1 points here. They have nothing here. They have 1 point here. They have nothing here, so on and so forth. So they always have this kind of relationship to make sure that there's at least one side has 1 box on here to keep this kind of structure. So again, this project really showcased what Grasshopper can do in the real world projects. And this is our final solution. Okay, let's take a look of the rendered view. So if you really want to get deeper into this project, you can jump in and try to make those connections in between. Okay, so thank you so much for your time. Again, I'll post a Grasshopper file down in the description. Looking forward to see you in our next tutorial.